This episode introduces the Fennoscandia ice sheets thawing and the first Scandinavians' migration. It also introduces the uplift, the tsunami, and the formation of lakes caused by deglaciation. This video is about Fennoscandia, covered with glaciers in LGM, Last Glacial Maximum. Fennoscandia or Fennoscandinavia is a geographical term for the region that includes the Swedish, Norwegian peninsula, Finnish, Scandinavian, and Kola peninsulas. The name comes from the Latin words Fennia, Finland, and Scandia, Scandinavia. Finnish geologist Wilhelm Ramsay first used the term in 1898. The Fennoscandia shield formed about 3.1 billion years ago. All were melted and disappearing now, but 20,000 years ago, this place was covered by a vast glacier. In Fennoscandia, traces of melting glaciers can be found in many areas. The most representative is the fjord. A fjord is a U-shaped valley formed by glaciers in the past. And seawater invaded as the glacier melted after the end of the Ice Age and the coastline rose. The current process of fjord creation can be found in Greenland. In particular, the Norwegian coast of Vestlandet, or West Norway, is home to beautiful fjords. A prime example is Sonefjord in Vestlandet County. The maximum depth of Sonefjord is 1,307 meters, 4,288 feet, making it the deepest of the fjords. The water depth near the mouth is about 100 meters, 328 feet. The average width of the mainstream is about 4.5 kilometers, 2.8 miles. And the height of the cliffs surrounding the fjord averages more than 1,000 meters, 3,280 feet. During the last ice age, the thickness of the glaciers in the Sonefjord area reached up to 3 kilometers, 1.86 miles. Just imagining traveling to a place with beautiful nature made by glaciers makes me happy. There is another legacy left by glaciers here. You will see on the map that many lakes exist in Sweden, Norway, Finland, and Russia. The glacier has allowed people here to appreciate the beautiful scenery on a misty morning. Also, dense forests are an asset to them that many other countries do not have. 65% of Sweden's total area is covered by forest. Vänern is the third largest lake in Europe after Lake Ladoga and Lake Onega. Volvo, Ericsson, and IKEA are Swedish companies that are widely known to people around the world. In Norway, 72% of the country is mountainous, with flat tops eroded by glaciers. Forests account for 24%, and arable land is tiny. At 2,000 m above sea level, ice caps and glaciers remain. The fjords described earlier were gifted from glaciers. Norway's primary industries are fishing, oil, and services. It is also the country with the highest democracy index in the world. Finland, the land of Nokia and Linux, received a beautiful lake as a gift from a glacier. Southern Finland has many lakes. Beneath this lake is the Salpaselka Ridge running east-west. It is a terrain created by the accumulation of terminal moraine at the edge of the Baltic Ice Lake during the Younger Dryas Ice Age, 12,250 to 10,400 years ago. There are 3 ridges below the lake area and 1 ridge above it. The terminal moraine can now be found in Wardøy Glacier, Greenland. It's also accumulating at Penny Ice Cap on Canada's Baffin Island. In addition, the glacier flows from the Byam Martin Mountains ice cap on Bylot Island, Canada, creating a spectacular terminal moraine. It is called the mothership because of its shape. Finland, Norway, and Sweden differ in land area from other European countries. However, it has a relatively small population. The relationship between land area and the people of European countries can be easily understood by looking at the chart. The x-axis is the surface, and the y-axis is population. Most European countries are concentrated in the lower left corner of the chart. This means that the land area is small and the population is small. Countries with a large land area include Ukraine, France, Spain, and Sweden. Finland, Norway, Poland, Italy, the United Kingdom, and Germany are in the middle between large and small countries. As you can see from the chart, The three countries in Fennoscandia have a large land area but a population similar to that of other European countries. If the 2022 GDP announced by the IMF is converted into GDP per capita and plotted, you can see that these three countries are at a very high level. What kind of DNA do people living in this beautiful land have? Norwegian's dominant Y DNA is I1, R1A, and R1B. R1B is the highest at 32%. I1 is the highest in Sweden at 37%, and R1B at 21.5%. However, in Finland, the composition ratio is slightly different. Y-DNAN is the highest at 61.5%, followed by I1 at 28%. The proportion of R1A and R1B, which constitute the prominent paternal ancestry in Europeans today, is low. All three regions of maternal DNA are dominated by H and U5. Since when did their ancestors live in Fennoscandia? Archaeological evidence suggests that modern humans migrated here around 10,000 years ago when the glaciers began to melt. Before looking at their migration process, let's look at the deglaciation in Europe. To help understand the melting process, the thickness of the Fennoscandia ice sheet at the Last Glacial Maximum, LGM, 20,000 years ago is summarized. The thickness and deglaciation of ice were written by referring to a paper published in Nature Communications in October 2021. The article is linked in the description. In addition, please see the video Geography of Ice Age in Europe and Gravettian linked above for Eurasia vegetation in the LGM period. The map you are looking at shows the LGM Fennoscandia ice sheet's boundaries and thickness. The ice sheet's thickness reached up to 2,500 meters, 8,000 feet. From Hamburg and Berlin in the south to Mezen in Russia, the ice was 500 meters, 1,640 feet thick. The distance from the tip of the west coast of Denmark to Mezen in the north is a whopping 5,492 kilometers, 3,412 miles. At the edge of the ice sheet were the Palea Lakes. Over the Baltic Sea, ice was 1,000 meters to 1,500 meters, 3,280 feet to 4,921 feet thick. At the time, Oslo, Stockholm, and Helsinki were under 1,500 meters, 4,921 feet of ice. There was a 2,000 meters, 6,561 feet, massive ice sheet over the waters of the Bay of Bothnia. Between central Sweden and the Norwegian border, there was an ice age up to 2,500 meters, 8,200 feet thick. The glaciers of the North Sea melt first. According to the paper referenced, 17,500 before the present, much of the North Sea ice sheet had been melted. You'll find on the map that the glaciers on the British Isles have moved north. And the glaciers covering Denmark have also retreated north. Between Biren and Plok, the glacier retreated about 279 kilometers. And in the eastern Kara Sea, the deglaciation distance reached 500 kilometers. It is presumed that the North Sea was still connected to Doggerland. Doggerland has shrunk slightly. At 15,000 BP, the Fennoscandia ice sheet shrinks significantly. The ice sheet was almost melted in the United Kingdom except for Scotland and some highlands. LGM ended, and warming proceeded. After the late glacial interstadial, there was a temporary return to ice age conditions known as the Younger Dryas. The Younger Dryas began at 12,900 BP and ended at 11,700 BP. At this time, modern humans moved as far as north-central Europe. The archaeological industry in this area is called the Arensberg culture. There were people of the Bronkultur culture in present-day Denmark and the northern coast of the Baltic Sea. Archaeological excavations show that they hunted reindeer. It tells you that they lived while doing it. At 10,000 BP, all glaciers melt except in the highlands of Norway and Sweden. Sea levels were rising, submerging much of the Doggerland. However, the sea between Denmark and Sweden was still closed. A paper published in PLOS Biology in November 2018 suggests two scenarios for the first people's migration to Scandinavia. First, hunter-gatherers from Arensberg culture in Jurmund and Broms came to the west coast of Sweden in 9600 BC. The Arensbergians have engaged in fishing and seal catching as they migrated along the west coast of Sweden. As the ice receded, people moved northeast, and colonization continued. The paper suggests that in the second scenario, a population moved south along the west coast of Norway via northern Finland. And genome studies of early Scandinavian hunter-gatherers show that they met and mixed. The appearances of the two groups were different. Populations from the south had dark skin and blue eyes, while those arriving from the north had light skin and a variety of eye colors. What happened when the continental glacier holding down the Scandinavian crust suddenly disappeared? When the continental glacier melts and disappears, the mantle material rushes under the ice and begins to adjust to equal the weight of the continental glacier. An area called the asthenosphere is mainly affected by the adjustment, which is somewhat softer than the mantle. Would you like us to put some numbers in more detail? Suppose a continental ice sheet on a flat continental crust suddenly melted. Ice weighs 0.9 grams per cubic meter. In other words, the center of the Fennoscandia ice sheet, which was once about 3 kilometers thick, weighs 2,700 tons per square meter. And in just a few thousand years, that enormous weight disappears. And the land is made of granite and weighs 2.8 grams per cubic meter. The mantle weighs 3.3 grams per cubic meter. Then, as you can see on the screen, it is calculated that the crust needs to rise about 800 meters to balance based on the weight of the first ice. The area around the Scandinavian peninsula is known to have risen about 350 m since the last ice age. Scandinavia is still rising. The Baltic Sea is also uplifting, with the most significant uplift along the high coast of the western Bosnian Sea. It is known that he uplifted 286 m due to a postglacial isostatic rebound. The land uplift is the fastest in the Quark region, reaching nearly 1 centimeter per year. The Gulf of Bothnia could split in two within 2,000 years. When the ice retreated from Fennoscandia more than 10,000 years ago, the Earth's crust was depressed 500 meters due to the weight of the ice, which was 2 kilometers thick. The crust rose when the ice melted, and the recovery continued. Near the Gulf of Bothnia, where the ice was thickest, there is still some 100 meters to rise. There is another area where melted glaciers are thought to have been affected. It is the Storegga Slide on the edge of the continental shelf in the Norwegian Sea. Between about 8,255 BP 8170 BP, it collapsed and caused a massive tsunami. It was caused by a collapse of the continental shelf coast about 290 kilometers, 180 miles long. Streams of melting glaciers carried trillions of tons of sediment to the edge of the continental shelf, building up layers. An earthquake-like trigger caused the sediment to disintegrate and slide into the deep waters of the Norwegian Sea. Glaciers have greatly influenced the change of the Baltic Sea coastline. The ice melted rapidly in just a few thousand years, so vast amounts of water poured into the Baltic Sea. Also, as described earlier, the rebound of the Earth's surface caused the seafloor to rise. The Baltic Sea has undergone 4 phases of change during this period. Each of the 4 stages is given a different name: Baltic Ice Lake, Yoldia, and Silas, and Littorina. 14,500 to 11,500 years ago, the Baltic Sea was an ice lake. Because the water level in the lake was higher than the sea, the fire flowed out but not in. Between 11,500 and 10,700 years ago, it was called the Yoldia Sea. The ice reached north of Mount Billingen. Finally, the lake water could drain into the North Sea through a narrow corridor between the ice in the north and the mountains in the south. The lake's water level dropped by 25 meters in just a few years. A cooler climate lasted 200 years, and the ice did not melt during this period. As a result, outflow into the sea stopped, and salty seawater could enter through the corridor. 10,700 to 10,000 years ago, it was called Lake Ancylus. By 10,000, almost all of the ice had melted, so Scandinavia was uplifted due to postglacial rebound. This closes the corridor leading from Mount Billingen to the sea. The influx of salt water stopped, and the Baltic Sea became a closed freshwater lake again. As the last remaining ice melts, the water level rises by 5 to 10 centimeters per year. This opened a new outlet to the south towards the end of the Lake Ancylus period. The Baltic Sea is called the Littorina Sea between 10,000 and 3,000 years ago. Global ice melts and flows into the oceans during this time, raising sea levels. Sea levels in Scandinavia were also rising, but not faster than the worldwide sea level rise. An outlet opened between the Southern Sea and the Littorina Sea, allowing salt water to flow again. During this time, the Scandinavian ice melted completely, so no new freshwater flowed into the Baltic Sea. However, due to postglacial rebound, the land surface continued to rise, growing at 7 mm per year in the northern Baltic region. The screen now shows where DNA analysis was performed among the remains excavated from the site, where the Fennoscandia ice sheet used to be. Only pre-BC data are displayed. The number on the label means BC time. Information on these DNAs and migration routes will be introduced through another video. Thank you for watching until the end. Please give a thumbs up, subscribe, and turn on notifications.